Hello, my name is Frank McKenna. I'm going to give you now a quick demonstration of the OpenSees lab tool on NEEShub, and hopefully from the demonstration you will see why it is a useful tool and why you should be doing your large analysis on the machines available to you through NEEShub. So what I have is a little example here. The first thing I'm going to do is I'm going to tar this example up for sending it over to the hub machine. So now I'm going to run this example on my local machine. So there I have started the example now on my local machine. Now I'm going to go over to the hub here and I'm going to launch the OpenSees lab tool. Because I'm actually on a Macintosh machine using Firefox, I need to pop the tool outside the browser. So the first thing I want to do is within my tool I have a whole bunch of little tools. The first thing I'm going to do is download that file or upload the file to the browser, to the NEEShub machine. So now I've uploaded the file to the machine. Now inside my tool I'm going to select the OpenSees interpreter, which starts the OpenSees interpreter. From the prompt I'm going to extract that file I just uploaded. I'm going to CD into the directory containing the example, and I'm going to run it here on the hub. So now I've started the tool on the hub. As you see, it's a simple process. Put all your files into one directory, tar up the file or zip up the file if you're on Unix or Windows, and then just use the submit button to submit the tool. So now I've got the two tools running on the hub and on my local machine. Now I'll leave that running and I'll look into another tool here. Actually, let's do the lateral pile example. Just give me something to do while the two tools are running. So here's a little simple GUI for demonstrating the effect of lateral load on piles. Basically, it takes the lateral load, the L1 and L2 being the length above the ground and the length below the ground, whether the pile head is assumed to be fixed or free. And it has some soil properties you can play with. So I'm going to just simulate this example here now. And this shows you the pile displacement for, say, this fixed head condition. If I wanted to see what happens if I say vary one of the parameters, for example, I'm going to make the pile now, it's going to be pinned. So there's the results for the pile pinned. If I want to compare that, how did that compare with the case when the head was fixed? You see, here's the fixed head condition, here's the pinned head condition. If I'm not interested in the pile displacement, say I want to have a look at the bending moments in my pile, there they are. So that's the lateral pile analysis tool. We'll go back to our interpreter here yet and see if we're done. No, they're still going along here. Let's see if I want to... Here's another little tool I've come up with. So this will search the peer NGA database for records. You provide a criteria, your search criteria on the records. I'm actually going to cheat. I'm going to actually look at the records from a local file system. So there's the results. I could look at each individual, whatever record pops up. Again, I can change. I can play with the parameters, run it again, and see what happens. So let's go back and see if our tool is actually, the interpreter is actually done yet. Nope, we're still running. Okay. Well, we'll just sit here for a little minute until the tools are done. They should be finishing pretty soon here now. There we go. So they're The simulation on the hub is now finished, whereas the simulation on my laptop computer, the simulation that started first, it's still going. So now what I could do is tar up the directory and bring it all back to me. So the other one's done as well. So as you see, it took 195 seconds to complete this simulation on the hub versus 287 seconds on my local machine. On my local machine, it's a 1 year old, but it was a pretty expensive machine at the time. It has a lot of memory and it's a fast processor. So these machines that you have access to, they are very fast, and I encourage you to make use of them. To get the data back, I remember I just tarred it up into one file. So I'm just going to go get that example now again. There's that example. So I'm just going to now save it to my machine, and that's it done. There you go. That was an example of performing a simulation on the files in your local machine, uploading them to the hub, running them on the hub, and then downloading the files when you're done. There's also an example of why you should be using the hub to perform your analysis of large models. It's a very fast, you have access to very fast processors with lots of memory. I encourage you strongly to take advantage of it. They're free. So thank you.